Welcome back to question 4 of the series on falling body problems. The question reads, a boat is passing under a bridge. The deck of the boat is 15 meters below the bridge. A small package is to be dropped from the bridge onto the deck of the boat when the boat is 25 meters from just below the drop point. What boat speed is necessary to have the package land on the boat? With all these types of physics problems, a picture goes a long way. So let's draw out what we just read. We have a bridge, and let's assume that there's water underneath the bridge. And there's a boat that is passing underneath the bridge. This part right here says that the deck of the boat is 15 meters below the bridge. This means that if this is the drop point of the package, the distance from the drop point to the boat is 15 meters. So we'll represent that as x initial being 15 meters and x final, that's when it reaches the boat, is equal to 0. So I've represented the initial height as x sub 0 and the final height as simply x. We're also told that the boat is 25 meters from this drop point. So let's make note of that. And let's write down everything else that we know. So if the object is being dropped at this point here, the initial velocity will be 0 meters per second. Knowing the final velocity of the object isn't important in this case, so I'll just leave this blank. The acceleration due to gravity, which I'll represent as a, is negative 9.8 meters per second squared. I've chosen to make acceleration negative because I'm taking into account that the package is going down. But by all means, you could have left this as positive 9.8. And in that case, you would have to change these where this is 0 and that's 15 instead. The time is the most important part because using that and the fact that the boat is 25 meters away, we can actually find the speed of the boat so that the object will land on the boat once it reaches this point. Now, which of these formulas here ties together all of these variables? As you can see, this formula is what we need. So x is equal to 0. Minus 15, that's equal to the initial speed of 0 times t. Anything times 0 makes 0, so we can ignore this term, plus 0.5 times negative 9.8 t squared. By solving for t squared, we have found the time. It's really easy to solve for t squared. We take negative 15 on the left side, just leave it there. And to simplify this side, we have negative 4.9 t squared. Essentially 0.5 times negative 9.8 is negative 4.9. If we divide both sides by negative 4.9, this and that will cancel out. So using our calculator, we have 15. And remember, they're both negative, so don't worry about the negatives. Divided by 4.9 gives us this value. We square root both sides to find out what t is, and we get two values for t, one being 1.74 seconds, and the other one being negative 1.74 seconds, which we will not take into consideration. So that is the time it takes for the package to reach 15 meters below from where it was dropped. To find the speed of the boat, we take the distance and divide it by the time. So the distance from this boat to this point is 25, and this package will reach 15 meters down in 1.72 seconds, or 1.74, sorry. So I'll write down 1.74 seconds, dividing these out, 25 by 1.74 gives us a speed of 14.36 or 14.5 meters per second. That's the speed at which the boat needs to move for this package to touch the deck of the boat. Now, if you also want to take into account significant figures, notice that we started off with 2 digits here and 2 over here. So you can actually round your number off to 2 significant digits as well. So going back to this, you can simply write down 14 meters per second squared if you want to take into account significant figures. And so there you have it, another question on falling body problems.